All right, folks, welcome to more discussion of the fundamentals of statistics. We are going to be talking a little bit about another way of organizing information. So last time we talked about arranging information into frequency tables. Now we take the next step and we're going to turn those tables into graphs. So essentially a graph is basically a visual representation of data where the shape that graph takes represents the relative frequency of different scores. Because of that, it's usually easier to interpret than a table would be. You no longer have a bunch of numbers now just organized in rows and columns. Now you just have a shape to look at, and you can really quickly identify what sort of patterns are present in the data. So there are lots of different forms of graphs, but some of the most common forms of frequency graphs are first frequency polygons, and then the very closely related bar graphs and histograms. We'll talk a little about each one, and we'll talk specifically about how to make bar graphs and histograms. Then do a little bit of a review of some kind of basic rules or things that apply to making and presenting graphs. So starting at the beginning, a frequency polygon is something you've probably seen before. You're going to see it a lot later on in the course. But essentially, we convert our frequency tables into lines. So when we look at our frequency polygon here, we see that we have a line and there are dots above specific scores, in this case on a standardized test. And how high that or low that dot is reflects how frequent or infrequent that score is. Again, when we just connect the dots and we get kind of an overall shape of what we again call our distribution. Remember, that's an important term. So here, if you actually tally these up, there's somewhere a little bit north of 1,000 scores in this data set, but it's not intimidating at all when we convert it into this shape. We can see very quickly which scores are more or less common and where the scores tend to cluster. We would never be able to pick this out as readily if we were just looking at the raw data. So here is a frequency polygon of our car ownership data set that we talked about under frequency tables. One small note here in frequency polygons, we oftentimes start one score below the lowest score in the data set and finish one score above. This is so that the polygon, the line, starts and ends at 0. Even though -1 is a nonsense score, you can't own -1 cars, it doesn't matter. This is just to make it a little bit more easily digested. There's that rule where you just started at 0 frequency and ended at 0 frequency. So this is all the same data that was in our frequency table. It's been converted to a polygon. We're going to see a lot of different frequency polygons this semester, starting with the distribution shapes material that's going to come after this. So our next form of graph are different forms of bar graphs. So we've all seen bar graphs before. A bar graph involves just creating different bars over each score or range of scores, and the height of that bar tells you how frequent or infrequent the score is. So here's the difference between a bar graph and a histogram. A bar graph will visually have a little bit of space between the bars. We put a little visual gap there. This is usually used for discrete scales, and the little gap reflects the fact that those in-between values don't exist, that you jump immediately from a score of 1 to a score of 2. There's no 1.2, 1.3, whatever. Those in-between decimal values don't exist. That little visual separation indicates that for a new viewer. A histogram is exactly the same as a bar graph, except that little gap goes away. The bars now immediately border one another. This is done for, as you can probably guess, continuous scales, and the reason why, again, is that it represents that those scores are a continuum. Even though we're representing them usually as whole numbers, there are lots of those in-between fractional values to account for. So they are made identically except for that visual gap, and again, we add that visual gap in a bar graph because we're displaying discrete data. We eliminate that gap in a histogram because we're displaying continuous data. So here's how we make a histogram, and of course a bar graph is going to be exactly the same, just with visual gaps. First, make a frequency table. We already learned how to do that. Then we essentially put the values across the bottom of the page, what we call the x-axis, and from left to right, we organize it from the lowest to the highest scores that are in your data set. If you had a group frequency table, you'd use the intervals, but spoiler alert, we're not actually ever going to do that in this course. We're just going to be dealing with individual scores. So you organize the scores from lowest to highest along that x-axis on the bottom of your graph, and then the y-axis, the horizontal axis, the vertical axis, is where we are going to place our frequencies. Frequencies start at 0 at the bottom, and then usually we go just a little bit higher than the highest frequency for that value to add a little negative space on the top. Then you just draw a bar. You draw a bar above each value in your data set, and the height is the frequency of that value. Of course, a bar graph, as I mentioned, is exactly the same thing, but the bars do not touch. So here is our, again, car data set. It is represented as is that a histogram or a bar graph? It's a bar graph. Why are we using a bar graph? Because this is a discrete scale. There are no in-between values. If it was a continuous scale, it would look just like this, but with the little gaps gone. So over here we have the number of cars owned from 0 to 4. Those are the values that show up in the data set. Here we have the frequency. Again, here displayed as count. It starts at 0. It goes up in equal intervals. The most frequent score is 6. We leave a little bit of extra space up there so there's a clear roof on that bar. Again, puts that data in a more digestible form. Here's a visual example of a bar graph that people have made of what month they were born in. So these are kids in a classroom, and they're organized by what month their birthday's in. And I think our October, November, December kids got cut off there. Again, it's a nice visual way of displaying just how common or uncommon different birthdays are. Sorry, February. So that's how we assemble these, again, frequency polygons, bar graphs, and histograms. But some general rules of how graphs are used. So graphs are really commonly used because they make complex data very easy to process for a lot of people. So there are some general standards. We want to start the frequency at 0 and extend it to the very highest value, the highest frequency in the data set. We want to use equal intervals, and we want the graph to be wider than it is tall. That's just for visual sake. People process that a little more easily. Here's an example of the same data set displayed in a way that is accurate versus misleading. This is the frequency of handgun murders from 96 to 2000 according to the FBI. And we can see here there's a decline over that 5-year period. Here's the same data presented in a way that's misleading. These are all the same numbers, but they're organized a little differently. What did they change? Take a look. What's different about this one on the right? This one starts from a frequency of 0 and moves up in equal intervals, and this one starts at 5,000. It's basically cutting the top half off of this graph. The effect, it makes the decrease look more dramatic than it actually is. By zooming in, trends will seem exaggerated. They will seem more serious than they actually are. Once in a while in psychology, we'll violate those rules out of necessity. Here's a measure of reaction time. Very small differences in reaction time can be statistically meaningful. This graph here is not very useful. We can see tiny little gaps there, but it's not enough to really pick up what's going on. There, we would break this rule and zoom in. There's the same data, but now the actual differences are much clearer. So we have rules of thumb, but they are not written in stone. Sometimes, if it's more convenient, if it serves the purposes of the graph, we will break those rules. So, to review, again, you now know how to make a frequency table, which is a basic way of organizing scores by frequency. We can make histograms and bar graphs. The height of each bar is how common or uncommon each value is from that frequency table. We can make a frequency polygon where we do the same idea, but instead of making bars, we make dots, and then we connect those dots. We're going to be seeing a lot of frequency polygons, and that's going to start with our next section on distribution shapes. Really important, again, piece of this first unit. I will see you there.